In this video, I'm going to talk to you about structural isomers, and we're going to learn how we can draw and systematically name for them. This is something that we're going to work more so in class. This links directly into this science understanding. Hydrocarbons can exist as different structural isomers. To get you thinking about structural isomers, I've got two sentences for you to read. The first one says here, the fat dog shook himself and then rolled over on the wet rug. The second one says the dog shook the fat rug, then rolled over and wet on himself. You might be wondering why I'm referring to these two sentences. Well, what we can see is that both sentences essentially use the same combination of words, but it's just the organization of them that can make each sentence mean something completely different. So we say that both sentences use the same words, have completely different meanings. And so you can think of this being the same case when we look at organic compounds. When we think of hydrocarbons, they can essentially be made up of the same stuff, but they can actually be something completely different. So we say structural isomers are compounds that have the same molecular formula, that is the same numbers and types of atoms, but they have a different structural formula. This means that they are arranged in a different way in 3 dimensions. This means also that we should be able to identify them differently by systematic nomenclature. Provided that two compounds have different names, it would mean that they would be structural isomers of one another. If they don't have a different name, then it means that they are essentially the same compound. If we look at one simple example here, we've got what we call butane, which is made up of 4 carbon atoms long. And what we know is that we can form something with the same atoms, but they are arranged in a different way. Over to the right side here, we've got another organic compound where it's got 3 carbon atoms in the longest chain, so it's a propane, and we have a methyl group attached to that second carbon. So this is called a 2-methyl propane. If we were to work out the molecular formula, for butane, firstly, it would be equal to C4H10. So we've got 4 carbon atoms, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. If we do the same thing for 2-methyl propane, 4 carbons, 3, 4, 5, 6, 7, 8, 9, 10. We can see that they have exactly the same molecular formula. But looking at the structures, we can see that they are, in actual fact, different substances. And the name of this gives it away here. Provided that we can assign these compounds with different names, it means that we've got what we call structural isomers present. These show you what might initially be perceived to be structural isomers, but in actual fact, these all represent the same compound. If we have a look at the naming process, remember it's to establish the longest chain of carbon atoms. In each case, you can see that there are 4 carbon atoms bonded in the longest chain, but they may just be slightly arranged in a different fashion. And that's because these bonds themselves are known to be able to rotate, and so when they rotate, they can look like they have a different structure, but in actual fact, they don't. We just say that these are different conformations of the one compound, and these would just represent butane. Only when you end up with 2 or more compounds that have different structures can we classify these as being structural isomers of one another. And that would be structural isomers of C4H10.